Olisani, you may begin.
Good morning, grade 9s. We are back again with our lesson. Hope you had a great and a wonderful long weekend. Today, it's back to business with me, myself, and I, your host, presenter Xolisani Mbatha. And thank you very much who has been touching base with me on Twitter at MbathaX or on Instagram at XKIM. I'm hoping everyone is ready for a great lesson as much as I'm ready to teach you today. So today, grade 9s, what you can expect is the following. The reactions today, the metal oxides reaction, non-metal oxides reaction, and obviously we're continuing with our balancing of the equations, reaction of iron, reactions of sulfur. That's what you can expect today, grade 9s. So last week I was working with some of you. I'm hoping today some of you again will also avail yourselves. But before we begin with today's lessons, grade 9, can we kindly go on to and check our homework? So remember that our videos and the slides are available at www.africateamgeeks.co.za, or you can obviously inbox me on my social media pages for more information. So there we have a homework corrections that we need to do. My host, my producer, Sispel, I would like to have any volunteers if we have, so that we can start our lesson. Do we have any volunteers to help us do these corrections today before we start with our today's lesson? Anyone can raise a hand and then we start working. Remember that we did say that when we are doing corrections, what we do is work together as a class. So do we have anyone? Let me do the first one. Remember when they say magnesium burns in air, so we said we have to obviously first convert our word equation into chemical equation. We are going to use our, what you call our periodic table. And then how do we represent magnesium in our periodic table? It's Mg reacting with oxygen. Remember, to give us magnesium oxide. Remember that. So I'm waiting for any volunteers to do number 2 with me so that we can, then what you do after converting the equation into a chemical equation, like you're using symbol equation, we call it a symbol equation. After doing that, what do? We need to balance our equation. So you can see that we've got one magnesium on the right as well. So now we've got 2 oxygens on the right, on the left, and 1 oxygen on the left. So we need to balance this. Who balanced it like I am balancing now? How many of you balanced it like this? There is the correct answer for number 1. I'm still waiting for anyone who wants to work with me so that we can balance this. Aluminium reacts with aluminum burns in air. So I want us to do that one. Who did that one? Who balanced that one? Who wants to work with me in balancing that one?
Gosi has opened the
mic.
Yeah.
Godfrey. Morning, Godfrey. Morning, Godfrey.
Nkosi.
Who?
Nkosi.
Nkosi again. Hey, Nkosi, good morning.
Morning, sir.
How are you, Nkosi?
Fine, and you, sir?
How was your weekend? Did you have a great one?
Yes, sir.
Okay, let us work. We've got aluminium burning in air. We need to convert that equation back into our chemical symbol. How do we do that?
Al.
Al reacts with?
Al plus O2.
We said we are reacting now. We don't say plus. We are not in the mathematics class.
Yeah.
Reacts with O2. What do we get?
we get aluminum oxide, which is ALO.
Then is the equation balanced, Nkosi?
No, sir.
Let us balance it, my boy.
We need to put a 2 in front of aluminum
Where, on the left or on the right?
on the left.
Why? Why on the
'Cause
left? So remember, Nkosi, I said we look at the oxygen first, right?
Yeah.
So oxygen there is 2 on the left. We've got 2 oxygen atoms, right? You can see that. On the
Yes.
left, we've got 1 oxygen atom. Therefore, that
Yes.
means we need to put a 2 here first. Are you clear?
Yes, sir.
So now our oxygens are balancing. What is not balancing is aluminium.
Aluminum.
Then we put 2 here, my boy. We're good to go. Let us continue, my boy. We have lead, which burns in air.
Lead.
Lead burns in air. So from your periodic table, what is the symbol for lead? Nkosi?
Sir, I'm not sure with the symbol.
No, you need to be sure. Check on your periodic table.
Umkabeti has raised.
Okay. Unkabeti.
Yes, sir.
How are
Sir,
you,
the lead
Unkabeti?
sim- I'm good, and you, sir?
I'm good. And then the lead is a metal. What is the symbol for lead?
PB.
PB. And then reacts with
Oxygen.
oxygen. What do we get?
PBO.
Which is a, what do we name it?
I'm not.
It's lead oxide. Remember, when the metal reacts with oxygen, we're getting metal oxide. So this type of a metal is lead oxide. So is this equation balanced?
No, sir.
Let us balance it, Michael.
We need to put the 2 on the left-hand side.
Okay, we look at the oxygen, right? You with me, right? Then
Yes,
how
sir.
many oxygens do we have on the left?
2.
On the right?
None.
One. There is an oxygen there. It's 1. Then now, because we need to make 2, we're gonna put a 2 here. Then we've got 2 PBO, which is 2 lead oxide, right? But now
Yes,
our lead on the left is 1, so we're gonna put a 2 here. Then we've got a balanced equation. Are we clear?
Yes, sir. Thank you, sir.
Okay, and let's work with you, Michael. Let's work with this one. We've got potassium burning in air as well. Or what do we have there? How are we solving this one?
The potassium symbol is K.
It's K
Plus
reacting
O2.
with oxygen. Then what do we get? Potassium oxide, right? Which is
Yes,
K.
sir.
KO, right?
Yes, sir.
Is it KO? Yes, it is KO. Then you can see that we are still not balancing on it.
Yes, sir.
So we put a 2 here. Then we put a. Are you happy?
Yes, sir. It's balanced.
Let's do the last one, and then I let you go, Michael. Let us do the mercury. Mercury reacts.
It's Hg
It's
plus
H.
O.
Hg
G plus O.
O.
Yes.
No. O. It's a diatomic. Yes, it's a diatomic.
O236.
Thank you, Nkabetsi. Thank you. You are with me now. Then our product is a mercury oxide, right?
Yes, sir.
Then we need to balance. I said, where do we look first?
Oxygen.
And then how many oxygens do we have on the left?
2.
On the right, 1. Then we need
1.
to put a 2 here because 2 multiplied by 1 is 2. And then we've got 2 HGO. Then now our mercury is not balancing. gonna put a 2 here, of which we have this one. Are you happy, Nkabet?
Yes, sir.
Thank you very much for working with me. Please do continue enjoying the lesson.
Tabile had raised his or her hand as well.
Tabile.
Hello, sir.
How are you, Tabile? We are on number 2 now. You are defining the terms. You are helping Mr. Mbata to define the following terms.
Yes, sir.
So what is combustion?
Sir,
Tabile?
burning of a substance. Burning of a
Burning of a-
substance in air.
Yes,
Burning-
so you are very much correct, Tabile. It's a rapid chemical reaction. It's in simple terms, when you are explaining to kids who are not doing science, you just say it's a burning of a substance. But when you're explaining to your teacher, you say it's a rapid chemical reaction that happens with oxygen, right?
Yes, sir.
With oxygen. And what does it produce? That produces heat and light. Produces
Heat and light.
heat and light. So you see, it's the same thing that you said. It's just the burning of a substance. Obviously, when something burns, you get heat and light. But then what is rusting?
The common term for corrosion of iron and steel.
In the presence of? You are right. It's a reaction between oxygen and steel in the presence of. That's what makes it to rust.
Okay, sir.
In the presence of water. Remember? It's a slow chemical reaction. It's a slow chemical reaction of iron with oxygen. Remember this from the last week, right? With oxygen
Yes, sir.
in the air. In the air. Don't go anywhere, Tabile. We're gonna finish now. In the presence of water. In the presence of water. That's why we get a rust, because there is H2O there. In the presence of water. Then what did we say it was? Corrosion.
Rusting of a material by chemical reaction with the environment.
Mr. Mbata is impressed. So it's a process where a metal is damaged or weakened,
Yes.
or it's made weak, like weakened by chemical by a chemical reaction, right?
Yes,
A
sir.
chemical reaction. So let us go and balance the following equation so that I can let you go, Tabile. Thank you very much for assisting there.
Yes,
So
sir.
let us move on with our lesson. You were in class last week. So they say balance this one. Carbon reacts with oxygen. Carbon reacts with oxygen. So what is the first step do we do when the carbon is reacting with oxygen, Tabila?
Sir, can I please check my periodic table just now?
Yes, you can. 2 seconds. So we've got carbon reacting with oxygen. So the first step that you do for you to be able to actually solve your equation, you need to convert from word equation into a symbol equation. So we say carbon reacts with oxygen. What happens there? What is the symbol for carbon? C reacting with
O2.
O2. What do we get?
Carbon oxide.
No, it's not carbon oxide, but because we've got 2 oxygens here, it's going to be carbon what? You know this. It's carbon dioxide.
Carbon dioxide.
Yes, you get a carbon dioxide. Then Tabile, before I let you go and take another one, do you think our equation is balanced?
No, sir.
Look at it again, Michael. Is it balanced?
No.
Okay, let us count. How many carbons do we have on the left?
We have 1 carbon on the left,
How many carbons do we have on the right?
1,
How many oxygens do we have on the left?
2. Oh,
How
it's
many
balanced,
oxygens?
sir.
It is.
1
So we can
balanced,
conclude that our equation is
balanced, sir.
balanced. Thabile, please do enjoy the class. Let me get another one to work with me. Pearl, some 2 learners had raised their hands. Can I get their names? Who wants to work with Mr. Mbata in the class now? Let us all participate grade 9 so that we are sure that we are all understanding. Sulfur burns in pure oxygens. Who wants to assist Mr. Mbata? Anyone? Anyone? Let me go check on my Instagram who is going to help Mr. Mbata now. Can I please have, where's Yolanda? Do we have Yolanda in the classroom?
We have Lisander, whose mic is open.
Hi, Lisander. Lisander? Hello, Lisander. How are you, Lisander? Where's Tanya? Tanya?
There's no Tanya today.
Do we have Humi Kanja? Oh, whoever has opened the mic.
Yeah,
No one.
Lysander Johnson opened their mic, but Unkabetsi's hand is up. I don't know if it's still up. Oh,
Unkabeti.
Caitlin just opened her mic.
Hi, Caitlin. Caitlin? Oh, Caitlin. Okay, let me continue until someone talks to me then.
Sir.
Yes, how are you?
I'm fine, and you, sir?
I'm good.
So sulfur will react with the oxygen first, so it'll be S plus O2.
S plus. Why do we have O2? Why do we write it?
Because oxygen has 2 atoms of oxygen.
And we call it a diatomic molecule, right?
Yes, it's diatomic, so it's sulfur oxide, O2, or sulfur dioxide.
Alpha dioxide, thank you very much.
Welcome,
then can
sir.
I ask you to tell me, is the equation balanced?
Sir, it is balanced because you have 1 atom of sulfur and 2 atoms of oxygen on either side.
Thank you. Let's continue. Nitrogen burns in oxygen. So we're going to get what? What happens here?
Sir, it will be N plus
Yes.
O2.
Yes.
And the product will be NO2 nitrogen oxide.
And is our equation balanced?
Yes, sir. 1 atom of nitrogen on the left side, and 2 atoms of oxygen on the left side. So the equation is balanced.
Then before you go, let us do this one. Non-metal oxide reacts with what to give us non-metal oxides?
Sir, does it react with oxygen?
I'm asking you.
I'm
So yes, it is reacting with oxygen to give us non-metal oxide, right? So in your own words, what do you call a hypothesis?
So your hypothesis is your understanding or conclusion of what the...
No. Remember I said last week, if you check my notes, I said a hypothesis is a testable statement. Remember we did that last week, right? So you can actually now work the questions that I was teaching you last week, that you want to see what happens if you react carbon with oxygen, and then you will give your own prediction, and that will be your hypothesis, right?
Yes, sir.
You are with me? So don't
Yes,
go
sir.
because others are scared. Reactions of metals with oxygens, what do we get? If a metal reacts with oxygen, what do we get? So we get a metal oxide, remember?
Yes, sir.
metal oxide. Metal oxide. So here I want us to reverse the equations. To get sodium oxide like that, which elements reacted?
So sodium reacted with oxygen to create
So we
sodium
have
oxide.
sodium reacted with oxygen to give us that, right? So you can see what I did there, right? Then here we've got K2O.
Yeah, potassium reacted with oxygen to form potassium oxide.
Potassium reacted with oxygen. And then here, CaO, what happened?
So I'm not sure there for the element what it was.
It was calcium reacting with oxygen, and then we got calcium oxide. Can you see that?
Yes, thank you, sir.
Yeah, let's continue. And then ZNO, what reacted? So you are not with your periodic table there. That's what I can conclude.
Yeah, I'm not sitting with the periodic table, sir.
I told you you need to be friends with your periodic table. So here, what happened? Zinc reacted
zinc with oxygen.
With oxygen, right? Then we got zinc oxide here. Number last one, what did you do?
Copper reacted with oxygen to form copper oxide.
I'm happy. Oh, see me writing a word sentence again because of the excitement. So we have that. So you happy with this?
Yes, sir.
Okay, wait, don't go. I'm just gonna work with you for some time now so that we save time, because others to turn on their mics, it takes a bit of a time, so we end up left a bit behind and I have to rush through. But you are happy with this, right? Reaction of metals with oxygen, we're getting metal oxide, and then now you can reverse your equations, because it is very important to know what reacted to give us what product. Are we clear on that one?
Yes, sir.
Then we hear now reaction of okay, thank you. Join the class now. We are done with our corrections, but thank you very much. Please touch base with me on Instagram or WhatsApp for more information, and I'll also like to chat to you after this, so get in touch with me via Instagram, right? Okay,
right,
great. Night. I'm saying please touch base on Instagram with me, so that I give you more exercises like I've been with everyone who touches base with me, because you need to have more what you call more practice to understand these things, right?
Yes, sir.
Okay, so let us look at the reaction of iron with oxygen, grade 9s. We always said air contains oxygen. When iron is burnt in air, the reaction forms iron oxide. During combustion, Unkabetsi or Tabile explained to us that combustion basically is a rapid chemical reaction with oxygen that produces heat and light. So when iron burns in air, the reaction forms iron oxide. So during combustion, iron can combine with oxygen in different ways. So when iron is reacting with oxygen, the product is not always the same, grade 9. So you need to actually look when you are writing a test or a classwork, you need to actually read the statement, what is iron reacting with exactly? Let us look at this following example. When so you've got iron with oxygen, and then you get iron oxide. So symbol equation 1, the first equation that you can get, it's going to be Fe reacting with oxygen. With oxygen, you get, please write down grade 9, you get iron oxide. Are we clear?
Yes, sir.
Then if I'm moving too fast, grade 9, please tell me, calm down. I will. Then you get iron oxide. before we balance it, I want us to look at this, the second product now. You get iron also reacting with oxygen. It gives you iron oxide as well. I want you to look at this. Why do we have two different products for a same reactants? So this one, grade 9, it's iron oxide, yes, but is the one that happens in the presence of H2O, and we call it rust. This will be your rust.
So
Then-
shouldn't H2O be present in the formula in order for it to form rust?
No, it shouldn't. You know why? Do you want
No,
to know?
sir. Yes, please.
Because it catches water in the air. Do you understand?
Yes,
So,
I do. Thank you.
yes. Then this one, it's a magnetite. You know a magnetite? A magnetite is that obviously, how do I explain it in English? A magnetite is it's a magnetic black substance. You know that one? When you attach it to a steel, and then you get this one, a magnetite, and then it's Fe3O4. That's a magnetite. And then Fe2O3 is a rust. So now I want you to assist me in balancing symbol equation 1. Are you still there?
Yes, sir. I'm here. I'm just processing it.
Okay, while you process it, let me write it again so that we can balance it. We're getting Fe2O3, which is a rust. So now let us balance it. It's not balanced. So I want to see that you are following when it comes to balancing. How do we balance it? So you are there, right? Look at me now. You're gonna help me balance the magnetite one. So now we've got iron reacting with oxygen, and then on the left side, on the right hand side, we've got Fe2 and then O3. So now we've got 2 ions on the left, on the right, and 1 ion on the left. We've got 2 oxygens on the left and 3 oxygens on the right. So now what's going to happen here? We're gonna put a 2 here. Then we're gonna have 4 ions and 6 oxygens. So we're gonna put a 3 here to say we've got 6 oxygens, then our oxygens are balancing. Then we're gonna put a 4 here, and then we're gonna have a balanced equation. Did you see what I did there?
Yes, sir. Did you move some of the molecules around to be able to
Yes.
balance the equations?
Yes, you move the. Remember, we explained last week that during the reaction, the atoms are not gained or lost, but they are rearranged. That's why we put those coefficients there to actually add so that the equation is balanced, because you cannot have less and giving us more, or you get more
Sorry,
from
sir.
less. Yes,
You're going too fast.
I'm going too fast. Thank you very much. So I'm saying to you, we are counting the element or the atoms of the elements from both sides. I explained to you that we look at oxygen first. Whenever we are balancing, we need to look at our oxygen. So before we had, let me start afresh from here. This is what we had. We received this product from iron reacting with oxygen. We've got iron oxide, and then now iron oxide here is Fe2 subscript 2, and oxygen is O3 subscript 3. So now we know that during the reaction we do not gain or lose the atoms. So what happens is that they get rearranged. That's why we've got Fe2 and O3. The atoms were rearranged during this process to give us rust. So now I said to you, let us look at the oxygens. What can we do to balance them? Because now the reactants needs to be equal to the product. And now the product is a compound. It's no longer elements like element ion reacting with element oxygen. It's now compound ion oxide. So now we put a coefficient 2 here. Then when we've got 2 here, it's coefficient 2 multiplied by subscript 2, we're gonna get 4 ion. Then the coefficient 2 reacting with the subscript 3 of oxygen, we get 6 oxygen atoms. Then we come back and say, okay, let us look at our oxygen on the left, and then we've got 2, but we've got 6 on the right. Then we say, okay, 3, coefficient 3 of oxygen multiplied by subscript 2 of oxygen, we get 6. So now we've got balanced, but our ions are not balancing. On the right, we've got 4. On the left, we've got 1. So now we're gonna put a 4 as a coefficient here. Then now we're gonna have 4 ions, 6 oxygens on the left. And then on the right, we've got 4 ions and 6 oxygens. So our equation is balanced, grade 9. Let us look at the magnetite. Symbol equation 2. Then now we have Fe, which is ion reacting with oxygen. Ion reacts with oxygen to give us iron oxide, which is a magnetite now. We're all familiar with magnetite. So now what's going to happen is we're going to balance this one. So in your test or exam, grade 9s, the examiner will ask you, or your teacher will ask you, ion reacts with oxygen to give you iron oxide, which is rust. You must know it's Fe2O3, which is rust. Then when they say it's a magnetite, it's Fe3O4. You must be careful. That's why I made this, for you to understand it. And then I said to you, it is important for you to know how to balance, because every time you write an equation, you need to balance it. So now let us look at how we're going to balance our magnetite. We are going to balance our magnetite in this manner. Again, do I have someone who wants to balance the magnetite with me? After you've balanced rust, you should be aware how to, you should be familiar with balancing. Do I have anyone? Raise up your hand so that I can see you. Anyone who wants to
Yeah, sorry, so I don't know how to raise my hand, but I'm here. I can help with balancing.
Let's do it. Let's do it. So where do we look at first?
So you need to balance the right side to figure out what the left side would be first.
Yes. So how many oxygens do we have on the right?
So on the right, we have 4 oxygen atoms, and on the left, we only have 2. So we need to add more to the left side.
So we're gonna put a what here in oxygen?
We'll put 2 oxygen, sir.
Yes, coefficient 2. Then 2 by 2 is 4. Then now our oxygens, our ion. How many ions do we have on the left?
So on the left side, we have 1. On the right side, we have 3. So we need to balance the left by adding a 3 to the left side.
Then is our equation balanced?
Yes, sir. It is now balanced with 4 oxygen on left and right and 3 iron on left and right.
I'm impressed. I'm impressed, and we are going very fast with you. I hope everyone else is understanding here. Do you want to explain to your fellow classmates how you did it here? You added the atoms, right? And you need to reiterate to them that we do not actually lose atoms during the reaction, but they are conserved, so they stay the same. That's why we maintain them to be equal from the left and right, because our reaction doesn't get more or less during the reaction. So we need to maintain them. That's why we add the coefficients, right?
Yes, sir.
We cannot have less giving us more, or we get less from more. That's why we need to balance our equations at all times. And then, thank you. Let me continue. Don't go anywhere. We'll work. There's this one I want you to assist me with. Reaction of magnesium with oxygen. So we're also looking at magnesium. We all know that magnesium, from the periodic table, magnesium is a metal. So now when it reacts with oxygen, we are going to get a magnesium oxide. They say it forms a white powder called a magnesium oxide. So magnesium reacts with oxygen to give us a magnesium oxide. Let us work on the word equation. Assist me. I'm waiting for directives what to type for magnesium oxide to symbol.
So for magnesium, it is Hg plus O2.
8 for magnesium. Please check your oh, you don't have your periodic.
Sorry, sir. Sorry, sir.
Yes.
Yeah. Is it Mg plus O2?
Mg. I like how you actually turn everything around for me to answer you. And then what do we get?
We get magnesium oxide, MgO2.
Nope. It's magnesium oxide, not dioxide. So
Okay,
we
so
get.
sorry.
No, you are learning. That's why you're here. Don't be sorry. So now help me balance it. Let's look at our oxygens first. How many oxygens do we have on the left?
On the left side, we have 2. On the right side, we only have 1. So we need to add 2 oxygen atoms to the right side.
Yes. And then what else is not balanced now after putting this 2?
I don't think the magnesium is balanced, sir.
So we're going to put a coefficient.
2 as well on the right side. Left side, sorry, sir.
Then there we go. You see, now you are coming all right. So we've got 2 magnesiums on the left and 2 magnesiums on the right. 2 oxygens on the left and 2 oxygens on the right. So let us move on. So they say write the right weight equation for the reactions that take place when the following metals burn in air. So we've got aluminium burns in air. What is it reacting with?
Sir, it's reacting with oxygen, so it will be Al plus.
No, it's
O2.
a word equation.
Oh, the word equation. So it will be oxygen reacting with aluminium, yes.
And then what do we get?
Aluminium oxide?
Yebo. Yebo. You can never be more than that correct. You are very much correct. Aluminium oxide. Then we've got potassium. What burning in air? What is it reacting with?
As the rest would also be, it will react with oxygen.
Oxygen, yes, thank you very much, all of them. Because, oh yeah, you read the instruction now, that's why you know. Oxygen. And then what do we get from here?
Potassium oxide, sir.
Potassium oxide, you see? Potassium oxide. This one was just to actually check if you read the instructions so that you don't make mistakes, you see? Because this one they said write the word equation. So we get lead oxide. So when metals are reacting with oxygen, we always get oxide.
Yes, sir.
It's mercury oxide as well. Nothing changes. Mercury oxide. So others would write mercury oxygen. Nope, it's mercury oxide, because now you're in grade 9. You know that when metals are reacting with oxygen, we get oxides. Then let's complete this one. We've been doing this one. Just now we've been doing it. What did iron react with to give us this? And is this a rust or is this a magnetite?
Sir, it is rust, the first one.
Yeah. And what did iron react with here?
It reacted with oxygen.
With oxygen. And then is our equation balanced?
No, sir.
Let's balance it.
We need 1 more oxygen atom on the left side and 2 oxygen atoms on the left side. Iron atoms on the left side.
So how are you going to do that?
So we have to write a coefficient 2 for oxygen or 3 for oxygen on the left side.
On the left side. How many ions do we have? 2. We have 2 here, ne? So I say let's put a coefficient 2 here. And then how many ions do we have now?
We have 4 ions, sir.
How many oxygens do we have now?
Combined, is it 5?
No, no, it's not. It's not. Remember, it's multiplication now.
So 6 oxygen, sir.
Yes. So now on the left, we need to have 6 oxygens as well. Which coefficient are we going to put here?
We'll put coefficient 3.
Then we've got 6 oxygens. Then which coefficient we're going to put for ion here?
Sir, coefficient 4, because there is only 1.
Yes. So it's going to be 4 by 1, and then it's going to give us 4. And then we can conclude that our equation is now balanced.
Yes, sir.
Do you agree? Do you agree?
Yes, sir.
Then we've got copper reacting with oxygen. What do we get?
We get copper oxide.
We get copper oxide. Then is our equation balanced?
No, sir, we are missing oxygen on the right side.
And then you're going to put a coefficient what here?
A coefficient 2.
Then it makes 2 copper and 2 oxygens on the right. And then on the left, we've got 2 oxygens and 1 copper. What do we need?
We have to add another 2 to copper on the left side.
And then we are balanced. Are we?
Yes, sir, we are.
And then what did lithium react with to give us lithium oxide?
It reacted with oxygen, sir.
With oxygen. Then we getting lithium oxide. And then please look at this compound, our product. Is the equation balanced?
I will tell you now, sir. Sir, I don't think it is, because the atoms belong to lithium, not to oxygen on the right side.
So what do we do to balance it? Remember that yes, the atoms do get rearranged during the reaction. So that's why we get a compound afterwards, because now if they don't get rearranged, that means we're going to get the reactants being equal to the reactants. So we want a compound afterwards. That's why we have a lithium oxide there. But now the atoms, molecules are not balancing. The subscripts, you see the subscript 2 here for lithium, we didn't have this side. So we need to balance now. How are we going to balance it? Look at oxygen. We've got 1 oxygen on the right and 2 oxygen on the left. So we're going to put a coefficient what?
2.
2. Then now we've got 2 oxygens and 2, but our lithiums are not balancing. Which coefficient are we going to put on the left?
We'll have to add 4 lithium, sir.
4 lithiums. Thank you very much. We're happy. Are you happy? Because
Yes,
I am. I am very, very happy. We've got that one now. We just need to put on a simple equation. These are nonmetals. We've already established that when nonmetals are reacting with oxygen, we get nonmetal oxides. Then now we've got carbon reacting with oxygen to give us carbon dioxide. Please give me the symbols.
Sir, CO2.
Never. C plus O2 to give us CO2. You are like on steroids today, very forward. I'm very happy because you are understanding. So I want you to look at this equation now. CO, which is carbon, reacting with oxygen, we're getting a CO2. Is the equation balanced?
Yes, sir.
It is balanced. So I want you to help me with this one. Sulfur reacts with oxygen to give us sulfur dioxide. The symbol for sulfur is?
Capital S.
Reacting with?
Oxygen.
Which is O2. What do we get?
Sulfur dioxide.
Sulfur dioxide, which is SO2, right?
Yes, sir.
Is the equation balanced?
Yes, sir, it is.
What can you say happens most of the time when the nonmetals react with oxygen?
I'm not too sure, sir.
You can conclude that most of the time when nonmetals are reacting with oxygen, we actually get the balanced equation. We don't need to put the coefficients. Can you see that?
Yes, sir.
When the non-metal carbon reacted with oxygen, you got carbon dioxide, which was already balanced. And when you get sulfur reacting with oxygen, and you get sulfur dioxide. And after the lesson, you can actually take a periodic table and look at non-metals and make them react with oxygen. I think you get most of them that they are automatically balanced. So we've already looked at this. We already know what is combustion, and we already know what are non-metal oxides. And so I want you to match this column. This is your homework, grade 9s. You need to match this column. So my producer will automatically put this, or if you want this, grade 9, hence I say you must touch base with me. You must just go on my inbox, and then I will give you these questions on your DMs. And remember, these compounds are made of elements that are joined together. We use symbols of elements to write the formulae for compounds. Compounds are pure substances formed by a chemical reaction between two or more different elements. And that was an example of how water is formed. So I remember that. These slides will be available on our site, www.africateamgeeks.co.za. You click on natural sciences, and then you will find all slides, including the last week's slides and today's slide. And then, and again, I ask you every time towards the end of the lesson to say, please touch base with me and tell me, Mr. Mbata, you moved too fast here. Or last week I did not understand this certain part of our chemistry. And then I will actually be glad to assist with that. And then you remember compounds get their names from the elements that they are made of. We use the name of the elements to develop the names of the compounds, grade 9. Look at the table below. So this is the example for our next lesson tomorrow, when we will be working with acids. Now tomorrow we'll be working with acids. When acids are reacting with when we're gonna have acids reacting with, let me be sure, reaction of acids with bases. So tomorrow is gonna be more complex equations. It's gonna be more complex equations tomorrow. Most of the work I will be doing most of revision as I'm continuing introducing you to new things. But please do our homework and then tomorrow, and please make sure that you get involved in our lessons so that you learn. We all learn by being involved. You don't learn by being at the back. So tomorrow we're doing reactions of acids with bases. I know that I've given you notes on that, but tomorrow it will be more of work. So if you did not get more notes on these things, please follow that link. You can get more of those links. Let us look at what we're doing tomorrow. As I'm saying, it's expanded opportunities tomorrow. We will be looking at the following: acids, bases, reaction, and we'll also recap on what is a pH value, and then reactions of acids with bases, reactions of acids with metals tomorrow. So you need to know that HCl, it's hydrochloric acid. And then you also know what is NH3, which is ammonia. You also need to know the formula for nitric acid. We'll be doing that tomorrow. Please be early, and please touch base with me as to what you don't understand, so that I can actually emphasize on those things during the lesson. We are here to help you, so don't hold back and be involved. Thank you to everyone who was involved today, and I'm happy with you guys. Enjoy the rest of the day. We still have other classes throughout the day, so please look at your timetable and enjoy the rest of the day. Thank you very much.
Thank you, sir.
Guys.
Bye.
Bye.
Bye, sir.
Bye, Nkosi.
Bye.
Bye.
Bye. Bye.
Bye.
Bye.
Bye.
Bye.
Have a great day. Bye.